Okay, so we're going to continue talking about combining like terms for just this one more video so I can show you some example problems. I've got some colored pencils over here in different colors that I'm going to use as we get into some more complicated problems. But let's just start off with the first one. The first example here we have is 9a minus 10a. So that means I'm starting out with 9 of those single long skinny rectangles, that x value, okay, and this time we're using a, but remember with variables the letter doesn't matter. So we're talking about 9 of these, and if I have 9 of them and I subtract 10 of them, what am I going to be left with? Well, I'm left with -1. I'm actually going to be in a deficit. I'm not going to have enough. So I'm left with -1a. Now, remember that this 1 is oftentimes left off because it's just widely accepted in the algebra math world that if there is not a number here in front of a variable, if there's not a number as a coefficient, then it's automatically assumed to be a 1. So -a would be the most simple way to write that. I have 9, I subtract 10, I have negative left. Okay, so then over here we have constants, okay, numbers that don't have variables, and then we also have these number with a variable, okay, a variable term. So what I'm going to do is I'm going to take my blue pencil and I'm going to underline, okay, my two constant terms. Then I'm going to underline in orange, okay, my variable term. So I can only combine constant with a constant. I can only combine a variable term with a variable term. They have to be like terms. So when I go to combine these, okay, the only things that I can combine are this 9 and this +5. So 9 and +5 is 14, and then we're left with this -6w, okay? It is left behind. So that is the only thing that I can find. Now I have -6 of these rods, okay, these long skinny rectangles, and I have 14 of the little squares, and nothing else can be combined. So when I go to write my answer, I always want to put something with my variable terms first, constants at the end, so it's -6w and a +14. Okay, that's how we combine those like terms. Alright, next example. We have 7p minus 1 minus 9p plus 5. So again, I have variable terms. I have a 7p and I have a -9p. Okay, and then constant terms, I have a -1 and a +5. So I'm going to combine my variable terms. That is 7p minus 9p, and then I'm going to combine these constants, -1 plus 5. So when I combine these, 7 minus 9 is -2, and -1 plus 5 is a +4. Okay, now these can no longer be combined because they are as simple as they can be. There is nothing else that I can combine this -2p with, nothing else I can combine that 4 with, so my final answer is going to be -2p plus 4. Alright, so we're going to keep moving now. So here, on this next one, I have the variable term a, okay, 26a. Now over here I have a -4a. Alright, now this is where those different colors would come in, because this green could represent my A's and this blue or this red could represent my B's. Now in a previous video I ran out of the same color, so it didn't matter at the time, but now this would matter. Now I can see that a red and a green are not the same, so they cannot be combined. Okay, so you want to be careful about this. The A's cannot be added to the B's. They have to only be added to themselves because they are like terms. So I'm going to color the B's in green. Okay, so I add my A's. So 26 minus 4, okay, remember there's a negative here, so 26 and negative 4 is going to be 22, and then we add the greens. 2 and 10 is 12b. So my final answer here is 22a and 12b, and they cannot be combined because a and b are different variables. They are represented by different values. Okay? All right. So then we moved down here. Okay, down here we have 5x squared and 7x squared. Okay, these are x squareds. These are your large squares. All right, and so if we want to represent 5 of them and 7 of them, we can combine those two, okay, and simplify that to 12x squared. And now there's nothing else to combine that with, so that's going to be our final answer. Same thing on this next example. We have n to the 5th and n to the 5th. Okay, they are the same variable term, n to the 5th, n to the 5th. So I'm going to combine these coefficients, negative 15 and 4. Negative 15 plus 4 is negative 11 n to the 5th. Notice that on all of these, okay, with exponents, these last two that I've done, I did not add the power. Okay, the power stays the same. It is still an x squared. It does not become an x to the 4th just because I add it together. Okay, so when I am adding, I do not change those exponents. The exponent stays. So over here, I'm adding again so that n to the 5th stays n to the 5th. It does not become n to the 10th. Okay, it stays. The only thing that we are changing here is the coefficient, the number of these squares. Okay, the number of that, not the actual item itself. All right, so a couple more examples here, and we will be done. I'm actually going to go ahead and stop here, and then I'll do one more video with a few more examples that get a little bit more detailed.